Hello everybody and welcome. We continue with structure sections, and here we consider the UPN channel. So again we have the build the web, and the main difference from UPE channel is that here we have sloped flange, non-parallel. So I will show you the main idea. If we extend the slope to the end, so we will have two primitives here. The first one will be simple rectangle, and second one is the right triangle. We have this primitive done. I will leave the link to this. So we have three primitives: first rectangle, second rectangle, and third one right triangle. Good. So everything remains just to add fillets if we need. I will add it just to visualize it. Okay, so this we have 4 and 5 millimeters. So I'll just add the fillets here, and I'll delete this line. And another fillet is here. We already we know how to build it. We have these primitives also done. I will leave also the video for these fillets, and everything will remain just to add fillet or to subtract. Since we have two fillets, I will just mirror this one for visualization, and we will code it. We will handle it in the code next. Okay, so I'll prepare the table with dimension as well, and also I prepared the expression for enum sizes. Again, I use ChatGPT AI to prepare the dimensions library, the dimensions dictionary, I mean. So you can use any AI you prefer, or even generate it directly in your Visual Studio Code or your IDE program. I also use them. It is quite helpful. So in short time, I receive needed dictionary, quite easy and helpful. So okay, let's start coding. Let's create our class, name it profile UPN, and it will be inherited from shape object as well. And we paste our prepared dimensions dictionary, and again it's very similar to profile UPE. We create the size class inherited from int enum and paste the values that I already prepared in the Excel table. This size class is based on int enum, which means that each size we define, for example UPN 100, is actually both a name and a number. So Python sees it is an integer value it can work with, but for us it's more readable and structured. Now let's start with the init function. We need the standard parameters s and size, which can be enum or integer type. Also we need the height and position. By default, also we'll set the position to position u.center. So now let's define our geometry. But first we need to resolve the size. We have already done the helper function, which we used in our UP profile, because our class can get the size either as a number or as an enum value. The resolve size function makes sure it always becomes the correct enum type. If we give it a number, it checks that the number exists in the dimensions dictionary and converts it to enum. But if we already give it the enum, it just uses it. Then let's assign all dimension variables we will use. So self.h equals d from h, self.b equals d with key b, self.b tw equals d with key tw, and self dot tf equals d tf, self dot r1 equals d from r1, self r2, okay, here pay attention, should be r2 not rd, and self ys equals d with ys key, and also self dot height equals height. Let's keep the height as a property of our object. So let's go into create geometry. So O1 equals self dot create geometry from S. We will define next this new function, and also we need to use super init method to return the O1 object. Okay, but at first we need to define some helping variables. I will show you the idea. Okay, so we will define this create geometry function will return shape object, and let's go into some theory. Okay, so TW, the thickness of web, that's clear. Then here it is defined, okay, we know that TF, it is flange thickness, it is measured in the middle of the flange. So if we have B like the length of the total length of the flange, we'll mark the middle of this flange, and here will be, okay, we need to explode first our 3D solid in order to snap the point. So the height of the flange in this point will be our TF variable. Good. Also, we have a slope of the flange, and by standard it is 8% slope. So what do we need? We need to define the length of this our box rectangle. I will name it flange length. Also, if you remember that we have here two primitives. First one is box rectangle, and second one is right triangle. So we need to calculate the height of the rectangle and the length of right triangle, because first one will be this flange length, and second length we should calculate. So this height of the rectangle I will call like TF underscore rect, and for the right triangle I will call it TF underscore slope. With this height of the slope it's quite easy, because it is flange length time 008, and then let's consider how we could calculate this TF rect. Okay, so if we know that in the middle of the flange we have TF height, we could also define this small piece of sloped part. It will be B divided by 2 times 008 again, because the slope is 8%. That's also clear. So we could use this expression to define TF rect, because TF rect, it is this TF minus that half of B times 008. Okay, good. So now let's introduce these variables into our code. of flange length equals self dot b minus self dot w, tw. Then tf slope equals flange length times 0.08, and tf rect equals self dot tf minus self dot b divided by 2. Pay attention here, we forgot about multiply it by 0.08. Okay, so it was mistake here. Anyway, we start with the box, which is the first and easiest part. It will be box with tw like length, and h it will be self h, and height is self height again. And we need to translate it to the left side, because as you remember, our default position is the middle of our UPN profile. After that, we need to build flange. As you remember, it consists of different primitives. It will have rectangle, right triangle, and fillets. So for this reason, I'll define a helper function, and I call it create flange. Inside it, first I calculate the slope angle in degrees, and then I will create a box. It is the straight part, this rectangle. I will do everything in the 0 point, and then I will move the flange where I need, to the left or whatever. Okay, so the rectangle. After that, we need also right triangle to the slope part. It will be O2. It will be right triangle. We also have this primitive already. I will leave the link on that video again under this video if you missed it. So also translate it to the top, I mean above this box we've just created. And also what remains, we need two fillets. One fillet we need to add. I will name it fillet add. It is also our recently created primitive fillet. So we need here, okay, here we had mistake, should be R2 not R1, but anyway, for this fillet which we add, we have to use R1 not R2. Yeah, R1. So let's correct here to R1, and the height will be self.height, and the angle will be 90 degrees plus our slope angles is 8%, but in degrees. And because it has more than 90 degrees, we have to rotate it back to catch our position of our fillets as in the life. And let's move it to the corner, to the left top corner of our flange. Its position. Yeah. Good. And also we need to design the fillet sub, which we will subtract from the flange. It will be also fillet. Radius will be R2, and height will be self.height, and angle will be also 90 plus slope angle in degrees, but we just need to rotate it more on 180 degrees in reference to previous fillet, and we need to translate it to the right corner of the flange. So by x we will translate it by flange length, and by y we will translate it by tf rect. And we just return O1 combine O2 and fillets add and subtract fillets sub. Quite easy, eh? And now we have a single flange ready. So next step, we create two of them. I define an array, call it flanges, and the first flange, I'll just move it to the bottom of our profile and move it back to the left on the half of flange length. That's clear, I think. And the second one, I have to move to the top, but I have to mirror it. So how to do it? I will rotate it by x on 180 degrees, and then I have to move it back by z-axis on the height of my profile. So I rotate it first and then move it by x again minus half of flange length, and by y half of UPN profile height, and by z it will self that height. Everything remains, just go to combine my bodies of web combine flanges and return. And we have all done. So let's test our work. I use already ready my first script module for that. I just comment this part of code, and I will check the first. I will check one instance. So let's choose some size 140 and some position just to check if it works. Let's say, I don't know, let's say left bottom corner. Okay, in AutoCAD we register our script, and don't forget to reload AutoCAD before you test your script. Okay, something is wrong, but as you remember that we made some mistakes in the beginning, so we have to fix them. The first one, if I remember correct, we forgot to use value of enum when we resolved our size. So here should be dot value. So I will add it, and let's check it again. So I will just reload AutoCAD, and we will test it again. Okay, good. So anyway, something is wrong. So what we have here? Okay, here, yes, here we forgot to multiply it by 0.08. Yes. So it was also a mistake. So let's try it again one more time. Okay, we received some geometry, but the flange is in incorrect position, and also the position is of UPN profile is not working, so we need to check it. Okay, we don't have this part of code. I will just copy it from UP profile, the translation of all the profile. It is the same logic, so I will make just copy paste. Okay, and also this one we need to tab. Good. Okay, so what remains? We need to correct this position of the flange. We need to move it down. And again, let's test if now it should be good. Okay. And then let's test all of the sizes. So I will just uncomment it and change everything on our UPN profile, and let's test it again. We need to reload AutoCAD. It's annoying. Okay, I understand to reload it every time, but what you can do now? Okay, perfect. So it's working. So one more primitive into our collection.